we identified more than. Hello, am I audible? Hello,
Yes, sir, you are audible.
yeah, ma'am. So,
But madam,
so
But
for
slide is
slide is
not
not
visible,
visible.
sir.
is it visible now?
Please share the screen, sir.
I've already shared.
No, sir, it's not visible. Please make
Not
the
visible.
Sorry, sir.
presentation.
Sorry for interruption.
Yes,
Slide,
sir.
sir, slide is visible now. Visible actually. Slide is visible.
Yeah.
You can continue.
Okay, sir. Okay, sir. So, whenever we are working in a medical scenario, this is the exact piece of work we will be doing in our own labs. Okay. So, wherever you are working in a nursing environment, the government has been given strict guidelines by the respective universities to develop a data imaging lab. Okay. So, what we do is first we identify the databases, say around 50,000 or 60,000 all documents.
Excuse me, sir, your slide is not visible.
Yes,
Sharma
sir,
sir,
slide is not visible. Actually, my candidate, I think they are not able to see it.
Yes, yes, sir.
Visible है.
It's not visible.
ma'am,
Visible.
I think it's visible because it's showing.
No, sir, no,
Sir,
not
only your
visible.
face is visible, but slide is not visible.
Not visible, sir.
Visible, sir. Not visible, sir, for me also.
Excuse sir.
Yes, sir.
Excuse sir.
Technical issue.
Yes, sir.
Sir, slide is visible here.
Okay.
Just a minute. You can share again. Just stop sharing, and then again you have to share on
Yes, sir.
screen.
I'm
Just
sharing it again.
Just
I'm
again.
closing my video.
Yes.
Yeah.
Yes, sir. Yes, sir. Thank you, sir.
Yeah, just a minute. So, I just want to go back and see the slide. Just a minute. There is some technical issue. I don't know.
Yes, sir.
Please remove this tab. Open your screen.
Yeah, I've opened my screen already. I think there is some disturbance. Just a minute. I'll switch on the PPT. I hope everybody can see my screen now. Is this visible to everybody now?
Yes, sir.
No, sir.
Yes, sir.
Yeah. So we will. I think this slide number 12 is visible to everybody now, right?
Yes,
Sir,
sir.
it is clear. Sir.
Yeah.
Now it's okay, sir.
Yeah, thank you, ma'am. So first, what we have done is we have identified more than 50,000 databases, and we have taken more than 59,000 files. Okay. From that, what we are doing, we are following a machine learning algorithm, and we have removed all the unwanted data. So we have screened around 25,000 from files from that, and we have this is 24,423 files which we require actually. And before that, what we have done, we have already ascertained that duplicate records are removed. Those are not necessary patients who have died down. We have removed those data. Where data is not correct, we have removed those files already to cross-check the error. Once we go to the level of the screening, once we are identifying 24,000 documents, then based on title and abstract, we are screening them first. Then if they are repetition, we are able to retrieve them from a database because they may be old data. Most of the government records are in this level where we are not able to retrieve that data. So that has to be manually picturized, scanned, and put into the database. Okay. Then what is going to happen is we are going on to the third, where we are going for a record assessment. Once we are going for that record assessment, we have to observe these articles where we are screening them, and then we are taking them to the next step. Okay. Now, if you see this, imagine you are working as a nursing officer and you have to do all the tests of a patient. So our regular procedure is to take them to the OPD, and from OPD, whatever the slip has been given out, mostly in government procedures, is to ask them to do a test and come back the next day. Now imagine there is a very critical situation of a patient who is in trauma care or needs an NICU. So how do we manage the time and the risk efforts? For that purposes, we are actually developing this intelligence. So this is an article that is taught often to people in nursing management. It's an interesting article. It says that artificial intelligence is described as the new electricity, just as electricity. When electricity was not there, we were all in dark. This is just to help us. It helps us to reach out. So by 2025, it is predicted that around $36.1 billion is being spent on digital app and systems. And you have seen the transformation that is occurring both in government and the private sector across the world. So what is actually happening now? For example, if I want to do a ECG or if I want to take a data, I just have to put on my smartwatch and press a switch. I have to develop a hologram and that report is available to me within 5 minutes. Now, that is the kind of speed we are looking to. So when Stanford University developed this AI, so how did they develop? The first thing that was developed was a Turing machine. That's the classical fundamental concept of developing AI. So two students, McCarthy and Dartmouth, what they did, they were lying after their summer vacation and were using the 10-bit machine. They developed what is called as a Turing machine. So from the Turing machine, system of calculation started. We started using all these vacuum tubes and supercomputers. Then what we did is, from supercomputers, we moved on to computation systems. From computation systems, we moved to the internet. And then we developed this, what we called as artificial intelligence. This has been the evolution of computers when we are trying. You can see this hype cycle actually. What happens is, there are 3 different phases when we are trying to use AI in nursing care. So first is, when you get the technology in your hands, there is a phase 1 which is called as a curiosity and excitement. You are very curious to try that app or a device or some new device, learn. That is the learning process you are getting there. So technology triggers that. It goes to a peak when all of you have been trained and you learn the devices. Now what had happened is, you start thinking, oh, this device is not that good compared to this. Then you start comparing between their different versions, different facilities. Then what happens is, you get a large set of data to work through. And that is why this downfall is there. So there is a disillusionment because you are trying to get a particular device and you have been given a particular device which does not match up to your expectations. So that is why this drastic changes is been there. From 80s, AI started to fall down. So this was disillusionment because everybody thought that AI is a substitute to human care in the nursing midwifery field. And that is why they stopped using AI for a long period of time. Then, with the advancement of the internet and awareness, global awareness on computation, we started again using AI. And today, this is the confident phase. This is how we are using it today. So gradually in the 21st, you have seen how this curve is actually going through. Like a learning growth phase is there is some stability, there is a decay curve, and that curve is again rising. So this is a paper which was produced in the IEEE in intelligent systems and computation. So during my 13 years work in the computation systems, we have been able to develop different kinds of algorithms, and my students have been able to develop this computer program. These are very easy and not like that biology people cannot do into computation systems. My background was biology, but I turned into artificial intelligence systems. So now what we are looking is, we are actually trying to develop a meta system where we are merging the artificial intelligence with the nursing. So if you can see the screen, the cognitive abilities we have been categorizing. If it is relating to some data, thinking, mathematical calculation, seeing and remembering, then we have to use this into AI. If it is relating to vision, it will go into imaging. If it is speech recognition, it will go into natural language processing. And then different kinds of puzzles will actually go into deep learning. So if we want to develop this AI, now coming batches, you have to be teaching students who are actually technologically more and more updated than most of us. And most of them will be coming through a background where they will be having either idea of Python or they will be having idea of R or Java and other coding languages. So we have to be teaching them in a scenario where we need to be computer educated. So now the obvious question is, which is better? Whether a personal care by a nursing officer or a nurse is better with a human patient, or you need a particular robot to interact. Now the question is, there is no substitute to human care and humanistic approach. This guy has been given to you for facilitating and decreasing your job load so that you are not stressed. Okay. So these are the 5 kinds of robots that have been used in AI. First is what is called as Buddy. This is mostly asked to youngsters during the examinations. So Buddy is a home robot. I've given you the links. I will be leaving my slides with sir so you can take it. Then is Sophia. So Sophia is for kids less than 8. It teaches them how to manage things, how to carry out different homeworks, when this was actually done for children whose both the parents are into jobs. So because they go into acute depression, okay, fear, phobias, in order to come out of that. So as a friend, Sophia started teaching. You can Google them into the YouTube and you can study about them. The links is about the home companion. It will guide you through. It's mostly for real estate and housing. It will help you through the house. Most developed was Miko 2. That was Japanese. So it was a kid's robot that understands emotions. It has been, the neural network has been trained to develop high emotional intelligence. So that mimics the sibling. So if you don't have a brother, and for children who are actually living alone, okay, they're single children, we have different kind of issues, identity issues. To deal with that, Miko was put into question. Then we have something called as Paro. So Paro was based on for animal therapy, playing with the different kinds of animals, like dogs. Then we have Pillow. Then we have Professor Einstein, which teaches you different kinds of robotics and health. Then we have something called as Sophia and Vertex. So these are the famous robots that have been used. Something to what looks like this. Now this is not a substitute for a nurse, definitely not. But this has been mimicked and made in such a way, it is apprehensive for kids and different kinds of functions for robotic surgeries. So generally we know that there are certain clinical procedures which require hours and hours of standing or holding on to a particular surgical instrument or carrying on. That is very taxing for one particular person. And imagine in government scenario, we are unable to deal with such procedures. For that, we have been using AI robots in different kinds of scenarios. Talking with the patients, doing a scanning for COVID procedures, scanning your data, then for explosive devices, hazardous chemicals, to monitor a patient, to take the patients to a particular scenario, to do a preliminary checkout, provide the first aid, talk to the person and take care of the person when other persons are not available. Okay. Now, though there are different kinds of risk involved. So you imagine if this is the size of your brain, you do a CT scan and you expose the patient to one particular kind of AI program, you sitting at one interface can actually see different kinds of data. Data that is coming from this face, from the CT scan, from the X-ray, from the different kinds of reception, from the inception, and from the different kind of clinical advice. So all this data can be available to you at one particular tip and at the same time within a fraction of seconds, and all correct, presumably correct. They also have different kinds of errors, but that is a different issue. Generally, when you are given a particular system that has been already trained with more than 10 lakh iteration, there are less chances of errors, but sometimes errors do occur. That will definitely need a physical, you will need a physical doctor and a nurse in every step to go through a monitor. Only it will be time saving and cost reduction is there. So now if you have the major questions that we will be discussing today is, what is the ethical issue on artificial intelligence if you are having? So ethical issue is when we are interacting on a person, whether they will have a humanistic approach, not till now. But if you are developing different kinds of emotional programs, Well, yes, to a certain extent, but they will not be a replacement definitely for human. Then, first is our emerging roles. So we should understand that whenever we are trying to develop a artificial intelligence robot, we are working in this red colored centered area where we will be needing some of artificial intelligence, a 5G network, a healthcare professional who will be guiding us, and all the applications are in this range which will be using for, so some are internet based, some are non-internet based, some are only interactive, and some are exclusively falling in the area of humanistic work. So this is the interface we are trying to develop a mind-body medicine where what we are doing, we are not actually trying to replace humans or biots. We are trying to basically create an interface where we make treatment very easily. This has to be understood. We do not have right to enter into the body of any particular individual. That code of ethics is still being followed. So whenever we are using AI, we have three levels of risk: low level of risk, intermediate level of risk, and a high level of risk. So for example, if you're using AI, you're doing natural language processing, you have a video documentation of a patient, you have a nursing report, you have an operative report, you have a post-operative documentation. There can be these three levels of risk in either of the documents. That has to be personally checked by a healthcare individual. There is no substitute for that. Okay. So what is the code of ethics? So nursing values and ethics described with interpreted statements that Anna believes that the appropriate use of AI will be there in practice supports, and the obligations of the professions are maintained in such a way that values are always protected. Human values are always protected. Nurses must ensure that advanced technologies do not compromise the nature of human interactions and relationships. This is central to the nursing profession. So this we are never compromising. There is no nursing profession without these two ethics. So once we are visualizing the impact of AI on healthcare, we have to be using this situation. So you can see the scenario what we have developed in the diagram, that one particular nurse is analyzing different kinds of data at the same point of time, and everybody is involved in different kind of work. So this interface will be available to you. In most of the NICUs in US and everything, we have a single LED panel which gives you all the data to be visualized by a nursing officer or a medical expert. So what are the recommendations? The recommendation is the code of ethics for nurses, that nurses, all roles are accountable for decisions made and actions taken in course of nursing practice. AI does not replace a nurse's decision-making statement, judgment, critical thinking, assessment skills, and the respect that you have. Mostly people did not take into AI because somewhere they thought that nurses' respect is going to be decreased. No, you are just using a device just like a watch or a car. So it doesn't in no way recomplements your respect. That is always be there. The care will always be there, and the risk of the profession is already there. So systems and technologies, you have to remember that systems and technologies will always be there that assist in clinical practice. Okay. Nurses are accountable in case of technology failure also. It is the human who is going to be accounted for the technology failure. Whenever you are having a technology, genetics, or an environmental science, there will be solutions, there will be human rights issues, there will be disparities. At both individual and personal level, we have to deal with the social fabric, the institutional problems, and the suffering of the people. That has to be done by a humanitarian approach. Because of rapidly evolving communication technology, nurses must be vigilant on posting images, recordings, intentionally or unintentionally. Privacy of a patient and a nurse has to be maintained at any cost. So AI doesn't have access to these kind of areas. Now, you can see a scenario where an old woman, a nursing officer is not there, but you have a digital AI nursing officer who is continuously responding to the needs of the patient. Of course, this is what Elon Musk has done. He has tried to put a particular chip into a brain. So this is a MPSoC, multiple silicon processor on chips, and that has been implanted into a brain to give you different kind of. It is a bio artificial neural network that has been developed. Okay, it mimics your human brain, but is not exactly the human brain. And then you can have a robotic delivery system. I gave you the examples. This is one of the robotic delivery systems called as Miko. I told you, for safe delivery, parturition, and other kinds of activities, which is done, all cesarean operations that is done by this robot, mostly in OBG field. Okay. So then you must always remember that in AI, the robot will hand you the stethoscope, but how to use the stethoscope and interpret the data that is shown to you, that we will always need you. There is no substitute for a nurse or a healthcare professional. We are only using this device to fetch things for us, fetch data for us. So integration of AI in practice must not alter the goals of the patient care. Your compassion, trust, and caring will fundamentally be always there. And these are some of the references that I've used for my work. I would like to now show you certain presentations of my own work actually. Just give me 1 second. I'm trying to open up the page. Okay. So when I was working, the first work in nursing informatics, when I was working during my PhD, I wanted to find the vaccine or a pattern for lung cancer actually. So this was the most difficult because in the area where I was there in Lucknow, around 1,000 patients, from 1,000 patients, only one patient had this non-small cell lung cancer. And mostly we had this idea that smokers developed lung cancer, whereas in Canada and other patients, it was found that children and women who were passive smokers who never smoked developed the disease. So that is that was my area of interest when I took into working into this. This was my first paper. So what I did is I tried to figure out a drug. I scanned more than 50,000 compounds. Okay. So this was the title of the paper. I did a mutational study of RAS subfamily. There are different families of domains of proteins, and I selected a domain and a drug to identify medicine against this kind of lung cancer disease. Prior to me, I can proudly say that prior to me, there is no pattern recognition anybody has studied in the field of lung cancer. After my work was published in the PubMed and the NIH, this is the NIH-based paper. I'll be showing that paper to you too also. That paper was published. Everybody started using this in pattern recognition actually. So I have used AI tool here. So what I've done is I've taken a structure. Can everybody see the screen?
Yes, sir.
Yes, sir.
Yes,
So what I've done
Yes,
is
sir.
I have taken the potential harmful drug. Okay. This is called as phosphostrol. It's a steroidal drug, you are aware, and it is mostly used for cancer treatment. Generally, it is available. So mostly when I took the study, now you can ask me why you take a dangerous study. Because I believed, looking into the structure and after these studies, that this can be potentially a prevention of a particular type of cancer. I'll show you that, how it did. So first I selected the structure. So out of 50,000 compounds, what I've done is I selected this particular kind of drug. I'll tell you how I did it actually, how we do that scanning which I was talking to you. So I selected this. So what I did is, first step is called as ligand screening. In that, I selected the drugs out of 50,000 compounds. And out of that 50,000 compounds, I did a primary screening, secondary, tertiary, and quaternary screening. So ultimately, from 50,000 compounds, I came down to 3 or 5 compounds. At the same time, I did the screening for my domain also. Lung cancer in a particular area of your protein. You know, protein is available for growth. When a cell undergoes a cell cycle, it goes through a different kinds of G1, G2, G3, S phase. Okay. So what happens is you select that particular domain which is responsible, not giving a particular general medicine for the treatment of cancer or a chemotherapy. Generally, what we how we approach cancer studies is go through a biochemical method, give a particular kind of chemotherapy. In this is called as drug drug targeted therapy. What we are doing, we are giving different kinds of therapeutics on that particular area of a particular protein in every cell. So that is very specific. So what I did, I used different kinds of tools. We can discuss that. It's beyond the purview of this lecture actually. So in bioinformatics, we use this kind of software that is available. Once I developed this, I'll show you different structures. These are the kind of approaches I have used. I've taken into drug designing. I looked into the toxicity of the compounds, did a detailed protein analysis, and I found the energy that was minimum. Minimum energy will be always stable in a particular protein. So I found this was the preliminary work. Much detailed work is there, but I wanted to show you. So I selected the particular protein sequence of a human, and this is my original sequence. With that, I found different kind of species, starting from different kinds of animals, and in monkeys, 99% of the DNA is similar. Okay, so I selected those kind of protein, and this is the structure of the protein. So I tried to find out where is my protein in a particular area and that particular drug sequence, which I can specifically target, rather than giving out any other drug in the market. Okay. So once I did that, these out of that 50,000 compounds, you can see tibolone, lizarol, hexastrol, tamoxifen, fedrazole, azoxymethane, and solimedrol. These are the general drugs that are available in a pharmacology unit against cancer. You see their bioavailability, how they're going. It is less than 30%. That means they're easily absorbed into your bloodstream. 100% absorption is there, and it is not toxic to the blood. If you calculate the log P values, the blood flow, inhibitor capacity, it is the minimum. So that is why when I did a toxicity test, the toxicity test, it was slightly toxic. I tried to test that into a mouse. During that time, animal studies were there. So fortunately or unfortunately, I finished this kind of study, and my entire set of data I had to change, because animal studies were banned. I tried to do that in human. Again, human studies were banned. So I had to discard my data. I put that into a stem cell line. I developed that into a stem cell line. And this is the data that I have developed in the stem cell line, artificially stem cultured in the own lab. Okay. After I find out this is supposed to be my data from the chemical analysis. From the bioinformatics, I have predicted this. When I tried to simulate, this is my ligand molecule, this is my chemical, and this is the structure of my protein. When I tried to simulate, I found whether this is the point or the site where actually my protein 2C2 domain is actually interacting with the drug, and whether it is outside or it is acting perfectly. And you find that there is a perfect match. So I would have taken 18 years to predict this drug is not efficacy, because it was already banned by the Indian Cancer Association and the NIOH. But when it was when it was injected to the pregnant rats, the newborn rats, they did not develop any kind of lung cancer. So it is not necessary that a particular paper or a research will tell you that this drug is bad, and the similar thing you will be carrying on in your study. That has also, so these are the models that are being used. So these are the kind of mutations. I predicted those mutations, and I studied that in my own work. So this is a similar kind of approach when I've used informatics data available. I've used a computation system to predict different disease in cancer research. You can do that for any particular disease. And that paper is already published in the NIOH. So just a minute. I just want to give my acknowledgements. That will be the end of the talk. And that is some of the research work I've shown you that I have done. I'm currently doing with all my students, and some students are awaiting, my PhD students also are awaiting certain kind of work. So that is the kind of work we are expecting from you people when you are going into the nursing field now. That traditional clinical scenario has already changed. So I thank the organizers of the conference. I thank the chairperson, conveners, secretary, and the guests who have been so patient to listen to me, my ideas. I thank the authors and the research colleagues who will be presenting the paper, and a special thanks to my friend Dr. Sharma and Dr. Vishnudev for their inspiration and support, who invited me to the conference. And I also thank to my research team and my students who are my inspiration for continuous struggle. And I thank you all for your patient listening, and I will be taking down the questions now.
Hello,
Thank you, sir.
Yeah, thank you, ma'am.
Thank you, sir.
Yeah.
Sir, first of all, I would like to take the questions with
Yeah,
your
ma'am.
permission.
Sure, ma'am. Sure, ma'am. Sure.
Thank you, sir. This
Yeah.
is Dr. Yogita Utade from Maharashtra.
Yeah, ma'am.
Sir, I just would like to congratulate you that whatever the study you have shown, it is very fantastic one. And I just wanted to ask whether, I mean, you have given for the pregnant rat and the newborn rat did not show any lung cancer sign. So whether it was a longitudinal study?
Yeah, it was, ma'am. I did that during the beginning of I did that work in CCMB. Dr. Lalji Singh was my mentor. He moved on
Okay.
to Banaras, and we continued this study in the surgical oncology lab in Banaras, where we were dealing with the patients also.
Okay,
Now,
sir.
because the guidelines came in, we had to stop the work. But
Yes.
we did this work for around 6.5 years in every possible model that we could study. Even Admetox was available. Now it is not available freely of cost.
Yes, sir. It's not
Yeah.
available, and even though, for the cancer patient, many drugs has been banned, as it is a genetic mutation. They have shown it, and
Actually,
recurrence of the drugs.
the problem is with most of the drugs is these are basically EGFR inhibitors actually.
Yes.
So
Right.
epidermal growth factors, EGFR inhibitors. This is a different domain actually. My
Okay.
domain 2CE2 utilizes some of this RAS subfamily has EGFR dominators, but I screened
Right.
them. This is my preliminary work. In my advanced PhD work, I have actually developed the pattern and the medicine and the fingerprint for the lung cancer cure. That was my PhD work. I didn't show that here. This is
Okay. Yeah.
some point
Basic
of
one.
discussion. Yeah, because
Yeah.
EGFR depends mostly on epigenetic and your body metabolism. So any
Yes.
particular drug or food that you are taking, that
Yeah.
increases your EGFR factor. So it's very difficult to monitor, and that is why biochemistry has done with so much of problems while dealing with cancer patients. So I
Yes,
didn't
sir.
take, and also this beyond RAS family proteins, other EGFR family subproteins, they are very resistant to the drugs that we are using in the market today because most of them are
Right.
steroidal drugs. So
Yes, sir.
if you do a in silico docking with them, you will find that your receptor pocket is not inside the particular functional protein. So there is
Right.
no efficacy. You take the drug for 1.5 hours, the patient lifespan is reduced to 50%.
Yes, sir.
So why do we go? This is called as actually reverse vaccinology or reverse molecular modeling approach. What I have taken, so that
Okay.
the entire span of say 10 years or 12 years, you can cut that out. Similar
Yes.
strategy was followed by the Bharat Biotech in COVID-19 vaccine actually.
Right.
So
Right.
at
Yes.
18 years, we have screened that to around 3 years. So that was during my work in Hyderabad actually. I was working as
Okay.
a scientist and we developed this protocol. It's a very easy protocol, ma'am. What we do is when I
Right.
screen the libraries, I found out that because most of the scientists are facing this difficulty that whenever they are progressing, this protein is continuously changing its domain.
Domain.
As it
Right.
is continuously mutating, a level of particular expression of EGFR2 in a particular cell, if you do a protein analysis or a plot analysis, GCMS, no matter whatever you do, because
Yes.
it's randomly changing, levels of protein expression will be very high.
Right.
So I cannot work on a particular factor which is continuously changing. This is very logical
Changing
about it.
one. Yeah.
So that was the
Yes, sir.
reason of taking this. And also in Canadian population, this was found in around 92% of women population and child population who are non-smokers.
Okay. Okay.
So I mimicked this, then I verified this data with all the patients, women, children. I've done that work in this line. It was a good approach. And then people have started taking into KRAS, MRAS, different subfamily actually.
Right.
Right.
Thank you, sir. Thank you for
I hope I answered
elaborating.
your question correctly.
Yeah, sir.
Yeah.
Sir, with your permission, if you could share your contact number with organization permission also, because
Sure.
I am also working in a breast cancer for the women.
Yeah,
So
see,
in this particular,
BRCA1
yeah,
and BRCA2 has similarity because it has RAS family protein. I had worked actually during my starting of PhD, ma'am. I worked for 3 years in Bracacine, and then I discovered lung cancer actually
Yeah.
by mistake.
Because
By
it's
mistake.
very nearer one. Yeah, it's very nearer one
And,
and very sensitive one.
In
sir.
my lab, I think 3 or 4 papers were there on Bracacine. They were actually my papers, but somebody
Yeah.
took the data. I can
Yeah.
help you with that. The organizer has my number. It's very easy. My mail is also there. You can put me a
Okay.
mail. I can type
Yes.
it here if the
Ye-
conveners give me the kind permission. Okay, I'll be sharing it here. Just give me one second. Can you see the screen, ma'am? Now?
Yes. Yes, sir.
Yeah, just a minute. Actually, I'm not very convenient with Google Meet. Generally, we go on to Zoom.
Yeah.
So that's having some issues. I'll put this into a message.
Yes. Yes, sir.
So my mail is jayantresearch@redfmail.com. And
Jayant
my
Research.
9050. This is my number.
Yes, sir.
And bioinformatics research can be done by all of your labs sitting in the lab. In
Yes, sir.
BRCA 1, what I've done is now we have done in directly assembly. And if you get a picture of
Yes, sir. Yes, sir.
if you have a picture of echo is there, ma'am.
Okay.
Yeah. So if you have a picture of a mammogram or the lung pathological study, that
Yes.
can be predicted by machine learning only. And you get the
Okay.
same result histopathological result.
Right, sir. Right, sir.
So that is a very short PhD. We can work for that. After the conference.
Sure, sir. I will contact you, sir, regarding this.
Yeah, ma'am. Thank you, ma'am.
Thank you, sir. Thank you, sir.
So any more questions?
Sir, there is no more question now.
Thank you.
Thank you, Dr. Janmisa, sir, for insightful and informative presentation about importance of artificial intelligence. I think you have told much more about artificial intelligence by the presentation, and I hope every participant will get benefited now and in future also. Thank you so much.
Thank you so much, sir. Thank you so much.
So much. Now our next speaker, Dr. Kavita Kelkar. She is Associate Professor, Dr. D.Y. Patil, College of Nursing, Pune. She will be talk about system design for remote healthcare. Ma'am, over to you, ma'am. Ma'am, Kavita, ma'am. Ma'am, hello. Dr. Kavita Kelkar, ma'am. You have joined or not? Hello. Kavita, ma'am. Please speak out.
Hello. Can you hear me?
Yes, ma'am.
Yeah, I'm there, sir. I'm there.
Yes. You can proceed, madam.
Yes, sir.
You can share your PPT on screen now.
Yes, sir. Sir, give me some time. I'm not able to share my slides. I will just see.
Sure, no.
Actually, I'm also not familiar with the Google Meet. We usually use the Zoom.
Okay, sir.
Yeah, yeah. If
Okay,
it is
okay, ma'am.
possible from your side, sir, from your side, if you are able to share.
Just I will just I share.
Slides are visible to all.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Sir, slideshow.
Yes, yes, ma'am.
Okay, okay. Good afternoon to everyone. Myself, Dr. Kavita Kelkar. I'm working as an associate professor in Dr. D.Y. Patil College of Nursing, Pimpri, Pune, Maharashtra. And first, I would like to thank to the organizing team for giving me this opportunity and speaking on system design for the remote healthcare. As my specialty is a community health nurse, so I'm very glad to speak about this. So we'll see one by, so today's session, I'm going to talk about what you mean by the remote healthcare. So definitely I'm not going to talk about the telemedicine and telenursing because already that concept we know. Then we are going to see about the history in India, how the remote healthcare system has established, and then what are the benefits are there and what are the actual system design are been there in our Indian setup. So I'm going to deal these sub points during my presentation. Sir, next slide. So we'll see the basic meaning of remote healthcare. So already I think you are aware about the telenursing and telemedicine, which was implemented for the remote healthcare. So actually, we'll see the basic meaning, that is a use of modern technology, that is a information and communication technology that encompasses like internet, mobile, wireless network, artificial intelligence, and the robotic, both the software and hardware we require to enable the caregivers. The enables the caregivers means you have to provide the patient who are not able to do the formal and informal. So formal means that patient or the family can afford the skilled person at home, or informal maybe a caretakers can take a role for the delivering the health services at their home. Home setup, and obviously the health professional like the physician, the nurses, now in the community that CHO, everybody those are working in the healthcare setup are able to monitor and assist the patient in their home setting. The main of this remote healthcare is to save the patient at the home setup and supporting their independent line from anywhere and anytime. Next slide, please. So again, another meaning, again, it is nothing but the healthcare applications which enables the person to meet with the healthcare professionals without going to the hospital by conducting the interviews through the audio, through the video or a correspondence. So professionals can meet the person online, and whatever the health issues that we can discuss. So you can see the pics that physician is seeing the reports and the patient is at the another side, and through the Zoom or through the video conferencing that things happen. So that is a literal meaning of, you can say, the remote healthcare. Next, we'll see the history of RMC, that is remote healthcare in India. It was started in 1996. That is a deployment of first indigenously developed hospital information software by Center for Development of Advanced Computing, Noida, at Sanjay Gandhi Postgraduate Institute of Medical Science, Lucknow. 2000, that ISRO, Indian Space Research Organization, has played a very important role to establish the telemedicine pilot project, and which was linked the Chennai Apollo Hospital with the Apollo Rural Hospital at Arogonda village in the Chittoor district of Andhra Pradesh. In 2001, actually the Dr. K. Ganpati, who is a neurosurgeon and namely known for the father of telemedicine in India, and which helped the setup for the Apollo Telemedicine Networking Foundation, Apollo Telehealth Services. And it was the first telemedicine network between the three institutions, that is the AIMS, PGIMR and HGPGIMS. Next slide, please. In 2003-2004, again, there was work done on satellite communication based on telemedicine nodes across the country by the ISRO for the tele-education and teleconsultation services. 2005, the Ministry of Health and Family Welfare taken a good initiatives to constitute the Indian Task Force for the telemedicine. And during the 11th 5-year plan, they have approved the budget for the e-health. In 2010, that HGPGIMS was made National Resource Center for Telemedicine by the Ministry of Health and Family Welfare. And in 2012, that electronic medical record and electronic health record standards by expert group of Ministry of Health Family Welfare established. So it was not stopped in 2012. Till I think the telemedicine and this remote RMC has worked a lot during the COVID-19 2020. The benefits of RMC, that is improving the quality of life. So whatever we are talking, that artificial intelligence and all vagara. So at the end, we want that quality care or the quality of patients or the community should be improved. Then reduction of stress and burden among the health professionals, because already we know that the population and the health professional ratio is already less. So always we are having, especially nobody is willing to work at the remote area, or we can say at the community level. So again, through this RMC, we can reduce the stress and burden among the health professionals. Then obviously the traveling cost for the patient as well for the health workers also. Then improving the resource in utilization and bed occupancy, lower the hospitalization, especially for the old age, because they want to be stay at the home, their comfort zone, and we can lower the hospitalization, and they are very prone to get for the various kind of infection. And the last one is that strong ethical and scientific base. So all AI, already in previous lecture or previous session, already sir said about the ethical things. So like the privacy, the security of that data. So all be taken care of this RMC, and it is useful, benefited for the patient as well as for the health case. Next slide, please, sir. So next, the core of the session is the system design for the remote healthcare. And these are the some points under that we are going to discuss again. The view of next generation remote healthcare system, then vital sign sensing technology and wireless sensor technology, signal processing architecture implementation methodologies, machine learning technologies, and the patient healthcare system. So you can see the image also. You can have a district hospital, specialized hospital, and that video through the various type of things like video conferencing. Then you will have that means patient to patient contact, and then we'll have that how that data is interpreted and storage at the central level, and how to disseminate at the specialty level and district level and the local level. So this is the infrastructure we can say, and you can say that system design for that. The next slide, sir. So again, the view of next generation remote healthcare. So first one is a remote monitoring and aids. So in that, these are the device allow allowed to provide and monitor, report, and analyze their patient acute and chronic conditions. So here I would like to give the example of blood pressure curve through the Bluetooth or through the now the digitally all various apps are available, so we can monitor the blood pressure in the like hypertension patient, those are chronic heart failure, then diabetes mellitus, kidney disease, because they are having the impact on the heart. So like this we can have the another example is the glucometer and the pulse oximeter. So patient in their home, the patient will be at home, and we can have these monitors or we can have these medical devices, and the data automatically reach to the maybe a CSC or maybe a district hospital, and there you can do the analysis and the further treatment we can plan. The next one is the ambient assisted, no sir, previous slide only, ambient assisted living. So visually we are focusing on the ADL, that is activity daily living of the patient, but in RMC or in that we are focusing on the ambient assisted living. So again it is a use of devices, medical devices, which always used to ensure that older person will be at home stay, and which include the smart devices and which connected to the wireless network, and some medical sensor will be also placed, and through that we'll get the data. Then next one is the electronic health record. At the last topic it is that, so I'm going to talk in detail. The next one is a distributed service architecture. Again, because the infrastructure, we don't need only the connectivity and all, so where we are going to store that data. So distributed services architecture is again it is a computing system of software component spread over the different computers, but running only in the single entirety. So there will be a workstation, computers will be there. Then there will be the personal computer used by the health professional, as well as the like tablet, then own mobiles, Android mobiles. And then there should be a local network connectivity will be there. And then everyone will have their own user ID and login. So because we have to secure the data, so those who are handling that patient or those who are handling that information, so everybody will get the authenticate user ID and password, and through that only that patient or that person can handle the data. The next one is a machine learning. So I think previous session also sir very nicely spoke about the machine learning. Again, it is nothing but the computing science that focus on the data and algorithm. Okay, so the example again I would like to give the like a medical imaging and the robotic surgeries. The next one is a 5G, so connectivity. So to get the data from local level to the district or nationally, globally, that data, so that internet facility and that connectivity is supposed to be very much good. So nowadays 5G network is being used, but I think in January 2022, 6G, that 6G network is also in placed, and they are also working for that lower latency, then security of the data and speed of the connectivity. So that is matter for the 5G. The next one is the Internet of medical things. So internet, it is again technology that autonomously collect and transmit the medical data over a network or and which is connected to the medical device, like a hardware infrastructure also will require, then software applications also will require. Again, would like to give the example of glucose monitoring, and some nowadays that indigenous sense and small packet pills are also available. So if you want to or capsule in the patient's body and you want to identify if anything goes wrong with the GI. So through that we can identify any abnormality in the GI system. The next one is a location technologies. Yes, definitely, because distance is very matter in community health services, or we can say that remote health care system. So nowadays I think we are also using that GPS. So GPS is nothing but the global positioning system. We can trace the patient, we can trace the maybe the village or person's place, and we can go and we can identify, and through that we can get the data. The next one is a distributed ledger technology. Again, it is a decentralized record keeping technology, and various nodes geographically spread over the cities, countries, and the organization, and it gives the data security and transparency. The next one is augmented and virtual reality. So again, augmented, this means a real world setting. The again example is a CCTV camera. Okay. And another one is a virtual reality, that is controlled by the system, which required the that head setting. Okay, so patient will have that, like nowadays various studies has been conducted on the virtual reality. The one example I would like to say that if the patient is going for the cardiac catheterization, and to reduce the anxiety, so the students can prepare, or that investigator had prepared the virtual the background, or we can say the how actually the procedure has happened, how the cardiac OT is been there pre and post. So everything there that the content will include, and it will shows to the patient. So sometimes, or it may be a the result we can assume that the patient will have the stress, because already virtually we have given the to the patient for the cardiac catheterization, and we are assumed that that anxiety and the stress will be very less. And the last one is a robotic. Again, already I say that previous sir has talked about various types of robotic, and nowadays the many hospital, like corporate hospital, and I don't know about the government hospital, but the private and the corporate hospital mostly they are using, they are taking the assistant for the robotic surgery. Next slide, sir, please. So these are the some overview of emerging technology for the next generation remote healthcare. So you can see that using the required telemedicine remote healthcare services. So we require all the gadget. Okay, then some are implants, some are medical devices like a lens. We can say that goggles. In fact, lecture the further slides we will get to know what are the medical devices are there. Then wearable watches are also there. Then location, that is a GPS, and then you can have the AR and AVR, then which is connected to the system, that is a edge and fog networking, and that communication channel, that is a central for the public cloud name. So maybe a public and private domain that will be there for the server, and this like this that data will transmit to from one place to another, and for that analysis and interpretation for the further treatment. Next slide, sir, please. The next point is that the vital signs sensing technology and sensor-based technology. Again, it is a medical devices which will monitor the essential physiological parameters such as the heart rate, blood pressure, respiratory rate, temperature. Nowadays, 7-lead ECG, SpO2, and sometimes in the old age people, the posture and activity, footstep, calorie burn, the sleep pattern. I think all that smartwatch, I think most of the, if we are using nowadays, those are very obese and obesity. They want to see that how much calorie they have burned and all vagara. So nowadays that all programs are there in the smartwatches, and we can use that for the patient also, and we can observe all these essential parameters. Next slide, sir. So contactless and implant-based sensors. So you can have this pictures. So here you can see that T-shirt. Then I'm not able to see, but again the various, you can see the band is also there. Then you can have the shirt, then shoes, socks. Then in this that glucometer, CCTV camera. Then this implant base for the ear, for the heart. Okay, for the stomach. So we can insert this, and you can get the data related to that particular system. Next slide, sir, please. The significance of this, it gives a real-time health tracking, that is for the early detection of abnormalities and improve the healthcare devices. Then mobile health technology using the smartphones, then apps, then variable technologies which help the manage to chronic illness by receiving and sending data directly between the patients and the providers, and which create the comprehensive picture of dynamic state of the patient's health and then everyday environment. Then sensor-based technology, when it is placed in the home or a hospital environment, which is in combination, which help the nurses to compose the text and multimedia messages, like sharing the photos and the videos with the specialized physician, and which will helps to monitor the body movements, collect the weight movements, and the environmental like a temperature, light, sound, and air quality. Okay, because now one more studies also I came across that the impact of light and sound again also has the influence on the quality of sleep, because most of the time in the hospitalization these parameters or these things are playing a very important role, but that induce the patient affect the patient's sleep, or indirectly that other parameters also. Next slide, sir, please. The next one is a signal processing architecture implementation methodology. Again, it is playing a very important role, which required the signal processing algorithm and which efficient the architectural implementation. So like your BAN, then your cloud, then nodes. So all this, I think, technological, this is all terminology which is related to the internet and all, but that facility is very, very important when you are monitoring the remote healthcare, and which will correspond, which will have the low complexity, means everyone should aware, or everyone can use this technology, and the another the benefit supposed to be a lower power consumption. Okay, so using that architectural implementation algorithm, architect holistic optimizing approach supposed to be there in RMC. Next slide, sir. Next slide, sir, please. So again, this is the architecture for the indoor positioning. The patient is in his home, so how you are going to navigate and tracking. So this is like a CCTV camera and a radio receiver. The sensor, like medical sensors, will be there. And then microphone touch will be the input touch. Sorry. Then voice hepatic feedback, and then the database with the learning capabilities. So these are the some like how the system is working at the indoor positioning. The next one. The technology used that is which is appropriate non-invasive application. I said blood pressure. Then taking use the high location short range of motion. Then IRUB applications for the high accuracy resolution in medical imaging, MRI and CT scan. Then wireless sensor network we use for the low cost and consumption infrastructure, support wide coverage with natural innovation as well as development of based SPS. The next one. So again, BAN is very important. BAN is nothing but the body area. What is that? That sensor smart application is near to the patient which will be accurate data and compose of smart sensor around the human body. Sensors are deployed inside the human body, called as the info bands, and video-based monitoring allows the patient to their doctors or medical staff via audio call or video call in smart devices. Then cloud computing technology is a powerful platform to hold the servers, because all this data we have stored for a long time and maybe a large amount. So the databases, the networking software, and the internet or alternate for the cost, pressure, flexible resources, status manage large amount of data of internet technology devices. So BAN and cloud technology are playing a very important role to analyze and the interpreted data of the patient. And it should be transferring to this data to the appropriate, maybe a specialized person or specialties physicians. The next one. The next one is a fog and edge computing. Again, it is a extension of your cloud computing, which takes cloud computing services very close to the internet of technology devices. And the fog computing architecture provide the real-time analysis and security of data by preserving the sensitive data and performing calculation closer to them. And the last one is the blockchain technology. Again, it is a cloud fog and edge computing technology which can give the security of data and transaction between the patient and monitoring technology. So you can see the slides. So the triangle also, that all medical sensor or vital sensor technology, sensing technology will be at this, and then edge devices which is very close to the patient, and then it will transmit it for the nodes which is present as the various across the cities, maybe across the cities, districts, states, and nationally, globally. And then cloud will be at the highest level, which will collect the data from periphery to central level. The next slide, sir, please. So again, you can see in the how it is implemented. So it is suppose it is a patient and it will have all sensors. Then it is very close to that local that body area networking supposed to be there, and that gateway through the smartphone and the tablet. Then personal you can say, and then should be a network supposed to be there, and then that wireless area network will be there, and through that data will be stored at the servers, and that medical information system will be transfer on to the maybe a particular maybe district hospital or specialized hospital. So these are the infrastructure or architectural infrastructure supposed to be there when you are talking about the RMC. Next slide, sir, please. So again, this is again another flow chart of how the remote monitoring system based on the architecture. So main is the application. So uses like a vital monitoring disease and the diagnosis. Then target population will be the neonates and the elderly person. Then architecture, we should have a sensor and the MC, that is medical microcontrol unit, and then sensory time. Then sensor placements should be up appropriately. Then wireless communication supposed to be there, and we can use the technology like a Bluetooth, BLE, Wi-Fi, Zubi. Then techniques, that is a MACU model. So again, MACU model, it is nothing but like how the Google will interpret if you are writing something, and then he will especially in the Gmail and all, like if you want to, they kindly see the attachment, so automatically that next word will come. So it is like that. Then mobility model, so some like old age people, if you want to see the mobility, then MAC protocol. Then two is that is for the EC, is the transfer of data between the two computer terminals. Then the game therapy, again, it is usually the gamification of therapy, especially for the mental health to assess the behavioral and emotional issues. Then corporate communication. So these are the some technology or techniques we are using. The challenges is again the requirement and the metrics. So total, if you see that 84 node setups in our country, the recent data, and 60, and it is the 60 specialized hospitals are connected to the 306 hospitals. So this is a brief you can say about the remote patient monitoring in based on the architectures. The next slide, sir, please. So again, another you can see the design, you can say. So again, here the all wireless and sensor bus, then how the edge, edge nodes, and then fog nodes, and then cloud data system will be there, and then how it is transmitted to the medical transportation, medical terminology, or we can say the interpretation of that data. The next slide. So again, same. How that sensor 1, sensor 2, sensor 3, wireless body area network supposed to be there. The gateway like your personal, maybe a mobile or maybe a laptop or maybe a notepad, and it required the data acquisition for this. And then tier 2 will require for the network access points. So already say that everyone should have their login ID and password if you want to access any medical and sensitive data. And then wireless area network supposed to be their internet, and then it will store to the hospital database or architecture applications, and through that at the central level we can use view that data. So this is the overall infrastructure of remote healthcare monitoring. The next slide, sir. So applications especially for the vital signs monitoring, then physical activities monitoring, then chronic disease monitoring, like especially the diabetes and then hypertension. Then nowadays the mental health monitoring also taken consideration at the RPM, and then facial and emotional recognition. So these are the common applications we are using the remote healthcare system. The next slide, sir. So the next concept is a machine learning technique for the remote healthcare. So again, it is a tool used for the healthcare to help the medical professionals to care for the patient and manage clinical data. It is an application of artificial intelligence and which involves the programs, computers to mimic how the people think and learn. So I think already in previous lecture also sir has talked about a lot about the machine learning, how that algorithm and the patient is how the machine learning is help the patient as well as for the health professionals. The next one, next slide. So how the application of machine learning in the healthcare, like a personalized treatment, if you want to take an appointment, so that various apps are available. So we can take an appointment virtually as well as you can go personally also. So that apps are available for the personalized treatment for the consultancy. Then fraud detection and prevention, especially related to your health insurance. Then early detection of disease, like I said, all your chronic illness like diabetes, hypertension, cancer. Then robot-assisted surgery, nowadays it's happen commonly. Then analyzing errors in prescription, assisting in clinical research and trials, drug discovery and development. Again, and the last one is automating image diagnosis, like your all kind of investigation, like your MRI, CT scan. So these machines are helping a lot to interpret the data in very appropriate manner. The next, the patient health record. This is the last aspect of your RMC. Again, it is a digital version of clinical information of a patient and which contain collection of the data, storing of data, and manipulating and using available clinical information in delivery of a patient health. So we'll see the content. Next slide, sir, please. So components, that electronic medical record which contain all diagnosis related content, then treatment plan, medication, lab investigation, physician and nurses notes, then all your flow charts like vital signs, medication chart, intake output, pre-operative, post-operative and discharge summary. The electronic health record which will include the patient demographic data, the medical history, medication history, any allergy, immunization and investigation data. So again, that electronic medical record is a part of your electronic health record. The next slide, sir, please. So the various software used by in-patient healthcare record. So if you talk about the ILNE, that is Arogya Hospital software. So you can store the patient's data, not even the nowadays the X-ray, then CT scan, instead of hard print, the patient is getting the soft copy of everything for his future use also, and it will stay in the hospital if further for the research purpose or any time the patient will visit. So we can access these apps and the software, and you can take that data. So various apps, not apps, the softwares are being used in the hospital to store the patient's data. The next one is the types of electronic medical record required. The cloud-based EM, that is electronic medical record which helps to access the information online at any time, and this allows you to locate your files from anywhere. You can have share the documents related to the patient, like a medical history, on the cloud servers. Then MAC electronic medical record, again it is related to your devices. Then multiple options like a Mac native device are available, and which create exclusively for the operating system, and which gives the solution for the ideal for medical practice. And we can use like it is like an app only, nowadays like everyone is use that Apple phone, so various advanced apps are available in that. So in that same way. Then mental health and behavioral, nowadays the mental health playing a very important thing. So electronic medical record also designed for identify the behavioral and mental health issues, and through that you can at the primary level we can identify the mental health issues. Okay, the next slide, sir. Then next one is ONC certified EMR. It is a standard and requirement that has been laid by the Office of National Coordinator of Health Information Technology, and which enable you to store and protect confidential and sensitive patients' data. And the last one is a medical billing. So this can be integrated with the medical billing software, which help to verify and process the insurance claim. So these are the some types of software used for the to store the medical record electronically. So I think this was about my topic. So if any query is there, so you can ask me. I know it is a little bit tricky because it is all related to the technology and the server and connectivity, so we have to used during the remote healthcare system.
Thank you, ma'am, for enlightening and informative presentation about system design for remote healthcare. Thank you so much, ma'am.
Okay, thank you. I would like to thank to all the organizing team once again, and all the audience for the patience listening. Already I have given this content to the organizing team. If you want for the reference, you can take it from there.
Okay, ma'am. Thank you.
Thank you very much, sir.
Now our next and last speaker of today's event is Dr. Rupali Milind Salvi, ma'am. Presently, she is working as professor at Bharati Vidyapeeth College of Nursing, Pune. She has 29 years of experience in clinical teaching, admission, and research. She has 104 publications in Web of Science, Scopus, International, National, and UGC Care Journal. She has also presented scientific paper at national and international conferences and has received Best Paper Award. She has authored a book on forensic nursing according to INS syllabus. The ma'am will talk about innovative healthcare technology and innovative ideas in healthcare. Over to you, ma'am. Dr. Rupali, ma'am.
Thank you, sir, for that excellent introduction. And I would request you to please share my slides.
Just a second, madam.
So until sir shares the slide, I want to thank the Federal Organization for Nursing Services, Jaipur, Rajasthan, Vedant Nursing College, Lunawara, Gujarat, the Chief Patron, Co-Patron, and the organizing president, Dr. Rajendra Prasad Sharma, and a good friend, Dr. Jagdish Sharma, for giving me this chance to be a resource person at such an august gathering.
Thank you, ma'am. Thank you so much. Madam, hello.
Yes, sir.
Madam, now slide is visible now?
Yes, slide is visible.
Oh,
so before we begin, I don't know if you have seen yesterday's news. Let me read out that small clip of news to you. Dressed in a sari, meet India's first ever AI teacher robot named Iris. She is deployed at KTCT Higher Secondary School, Thiruvananthapuram, Kerala. And this particular robot named Iris was a project initiated by the Niti Aayog. And this video of Iris is available on Instagram. You have to type India's first AI teacher robot. So friends, AI is here in India and it is here with us to stay. Next slide, please. So I have made my presentation under certain objectives. Next, please. We'll be going through each of these objectives slowly. So what is the need for healthcare innovation? We have faced with a new wave of innovation in healthcare. Innovation in diverse fields, mainly the three fields: technology, biopharmacy, and healthcare. And these innovations will change the way healthcare organizations prevent, diagnose, and treat disease. Innovation aims at the smartest and most committed, efficient healthcare. Next. So talking about IT innovation, there is mobile health, there is big data. What is big data? Big data is, in a very simple words, it is a large set of information. And whenever you say big data, you should think of the three V's. Data which contains greater variety, arriving at a higher volume with more velocity. So it is about variety, volume, and velocity. Then there is cloud computing. We'll talk about it later. AI, we are already speaking about it since morning. And then there is IoT. IoT is a network which has the ability to transfer data without human to human or human to computer interaction. Imagine how advanced it is. And as a result, our world is becoming more and more connected than ever before. And then there is O2O. O2O simply means online to offline strategy, which is powered by QR codes. All of us have joined with QR codes and with mobile payments and many other such smart startups. Next, please. So technology innovation, we are talking about robots. I heard Dr. Kavita speak a little bit about wearable technology. Even I will touch a little bit, very little on it. Then there is VR, AR. VR is virtual reality and artificial reality. These are breaking down barriers in the sectors such as healthcare, architecture, education, entertainment. And these technologies are during innovation, improving process, and they're also enhancing engagement. Then there is 3D printer. We'll come to it later. Artificial organ, regenerative medicine, and DNA. Next. So how technology has changed healthcare? Speaking about this, friends, many innovative leaps in health technology have been made throughout the centuries. And people have been practicing medicine, yet few have had so much of widespread influence or impact as digital technology. So as the healthcare industry faces new challenges, technology solutions are helping leaders to improve performance by increasing collaboration across the systems and managing costs. As demands on organization increases, healthcare technology can streamline the process, automate tasks, and improve workflows at a scale that is not possible for humans alone. So as providers at hospitals and health systems, we need to embrace this value-based health reimbursement models. These solutions are helping the healthcare professionals to improve the healthcare and create a better experience. In fact, I will tell you one research study about this when we go to the end of my presentation. Next, please. So there are some benefits of technology in healthcare. Basically, it is improving patient care and experiences, real-time information exchange, and flexibility for patients and clinicians. Next is AI technology in healthcare. Next, sir. So many current efforts to incorporate artificial intelligence in healthcare are focused on basically clinical-based support and uncovering useful insights from large collection of data. Healthcare organizations have accumulated so much data that it will be impossible to analyze it all without the help of AI. AI-enabled tools can sift the large and complex data sets generated from electronic records, notes, images, sensors, and devices to find trends that could improve the patient care and help the researchers to develop better treatments for medical conditions. Although AI technology is still relatively new, there are many cases that could benefit organizations across the healthcare industry and nursing in particular. Next is blockchain in healthcare. Next, sir. So what is blockchain technology? Blockchain technology in the healthcare industry offers a user-centered way for health information to be securely gathered, verified, and shared. Most blockchain systems, they provide a transparent, distributed ledger of records that cannot be changed without the changes being recorded. So this technology can be used to anonymize. Anonymize basically means anonymity and confidentiality of the patient's data. It safeguards the patient's data. At the same time, it provides full transparency and interoperability across diverse, distributed, and highly fragmented healthcare systems. Next, please. Cloud computing. I already heard Dr. Kavita say a little bit about this. But see, when we talk about cloud, most people think of cloud technology, that cloud is a place to store data. Yet cloud environments do more than passive data storage. What do? Cloud environments offer ways for healthcare organizations to build and customize applications that can automate how data moves through their information technology systems. Hybrid cloud environments in particular, they offer security features that can help the organizations to maintain compliance and with the regulations, giving them flexibility, and they need to move the data around wherever it needs to go. So this flexibility also provides healthcare providers with more options for updating existing legacy systems and the workflows. So cloud adoption opens up opportunities for the organizations to use AI and machine learning tools, which can help uncover hidden patterns and insight. Next, we'll come to telehealth technology. Next, sir. So what happened during the pandemic? During the COVID-19 pandemic, many providers, they pivoted to offering appointments through telemedicine. And many payers also adapted to these changes by offering equitable reimbursement for telemedicine. And hence, this became a level, where which was providing better billing options. So even after the pandemic has subsided, the technology ecosystem that supports telemedicine will most likely continue to persist. Why? Because of the convenience and the flexibility that it provides. Patients, especially people who live in the remote locations or who work outside of the traditional business hours, they appreciate having more options for connecting with clinicians, whether they are using video software on a computer or on a mobile app on their phones. Next, please. So let us see what is interoperability through technology. It is a seamless exchange of data across systems and organizations, which is crucial for driving digital transformation in the healthcare industry. It creates benefits for the patients and the providers. So when the clinicians have to do less work to find the information they need, they have more time to focus on making the best decision for their patients. Moreover, healthcare interoperability can lower the total cost of care by reducing the number of unnecessary or repeated tests, as well as by helping the clinicians to make the diagnosis sooner. Next, we'll see the applicability of healthcare technology. Next, sir. Now, I've divided it under 4 headings. The first is disease diagnosis and treatment. Using AI to process data like medical images, develop disease models can potentially help the clinicians to diagnose with more precision. About medical imaging, computers and AI models are particularly valuable in medical imaging because they can help turn pictures into numbers, and they can also detect trends. About healthcare operations, many hospitals and healthcare systems are starting to build improvements that they have seen with the electronic medical records and find other ways to systematically improve their operations. Then there is cloud technology, analytics, and mobile technology. They are just a few of the technologies that the organizations are using so that they can optimize their digital infrastructure. Then there is clinical research. Life science organizations are using technology to transform how clinical trials are being performed. Then there are smart devices like telehealth visits and sensors, which are used to support the decentralized trials and make data collection more effective, efficient, and convenient for all the people who participate. Next, please. So what is healthcare technology? It is application of organized knowledge and skills in the form of devices, vaccines, procedures, and systems. So there are 4 important things I'm speaking here: devices, vaccines, procedures, and systems, which are developed to solve a health problem and basically to improve the quality of lives. So let me enumerate top 10 medical innovations. Next, please. So first is next generation mRNA. So what is mRNA? Already my previous speakers have spoken about it. It is the messenger ribonucleic acid. Then there is PSMA targeted therapy in prostate cancer, which is the PET scan, which is done in prostate cancer to detect and to treat the prostate cancer. The new treatment for reduction of LDL. We all know LDL is the low density lipoprotein. It is a type of cholesterol, which is also called as a bad cholesterol. So when high levels of LDL are found, it raises the risk for heart disease and also for stroke. Then novel drug for treatment of type 2 diabetes. You'll see in point number 4 and 10, we are talking about diabetes and hypertension, which are lifestyle diseases and which is the thing happening all around us globally. So we need to deal with these diseases definitely and very quickly. And hence, medical innovations are moving towards solving these two issues. Then breakthrough treatment for postpartum depression, targeted medicine for hypertrophic cardiomyopathy, non-hormonal alternatives for menopause. We'll be talking a little bit about this later. Implants for severe paralysis, AI for early detection of sepsis, and I already spoke about predictive analytics and hypertension. Next, please. So upcoming medical innovations. What are the upcoming medical innovations? Advancing mRNA, which is, I just told you about the messenger ribonucleic acid. Then there is patients embracing telehealth, adapting to data integration and AI, securing healthcare data, creating new pharmaceutical products. I'll talk a little bit about this. I'll give you a very brief enumeration of how these pharmaceutical products have really benefited humanity at large. Then implementing 3D printing. 3D printing is basically creation of physical replica of anatomical structures by using the 3D printing. And then there is adjusting to wearables and in-home testing. I have a separate slide on this, which we will speak later. Next, we will see to the future of health, that is digital innovations. The first is, sir, connected digital care. That is remote patient monitoring is a key part of the Internet of Health. It allows the healthcare providers to monitor a wider range of patients. Next is AI. AI is playing an important role in the evolution of the Internet of Health because it has the ability to analyze and make sense of massive amounts of data, find patterns and make predictions. So AI can also assist in managing care by providing decision support. The third is real-world patient engagement in healthcare. Online communities where patients can share their experiences, what was their experience, and because of which they can support each other. Fourth one is increase in security for digital and health data. When we adopt to a data-centric approach, we can use encryption and employing AI for cyber security. A data-centric approach enables organizations to protect their data regardless of where it is stored. It may be on internet, it may be on servers, it may be on end-user devices. Basically, encryption is used to protect the data at rest and in transit, and it can also help protect digital and health data from cyber threats. And the fifth one in that is improving telehealth services. So some of the most common telehealth activities are remote patient monitoring, online doctor visits, virtual visits. Like for example, the remote patient monitoring can be used to help the patients with maybe chronic diseases like pain, and their condition can be monitored. Next. So let me just take you quickly through medical terminologies, and based on the purpose, let us see the application. So where prevention is concerned, it is vaccines, and vaccines have really helped humanity in a very big way. And iodized salt. There is screening, for example, it is pap smear and mammography. Diagnosis, ECG and blood tests. Treatment, ARV is the antiretroviral therapy, and appendectomy, and rehabilitation is hearing aids and physiotherapy. The different materials used are pharmaceuticals, biologics, and medical devices. And some miscellaneous could be medical procedures, surgical procedures, support systems, and managerial system. Next, please. So what is the evolution of medical innovation? This is a 3-milestone medical innovation, which has really helped humanity in a very big way. The first thing I would like to mention is vaccine, and that is the smallpox vaccine, which was invented in the year 1796. Then medical device, in which it is a hypodermic syringe in 1844. And then in pharmaceutical, it is artemisinin, that is in 1910. The R is missing there. Next. Then let us see some evolution of medical innovation from Edward Jenner to Gavi. About 20% of deaths in Europe were due to smallpox in the 19th century, and the last case of smallpox occurred in 1977. Almost 2.5 million deaths each year were prevented. Between 80 to 90% of infants, when they receive DPT, even their mortality and morbidity has come down. So I will quickly take you to the next slide, which speaks about, next slide, please, which is the evolution of medical devices. Like we were at a time where we were using adhesive plasters, and today we are with MRI. And in 1844, Francis Rind first recorded a subcutaneous injection. 1956, plastic disposable syringes were patented. 1.3 million deaths per year were saved because of unsafe injections. And then the auto-destruct syringes are now in place, and also pre-filled syringes. All of us are working in the clinical area, and we can remember with Fluxum how already it is preloaded and we just need to inject it to the patient. So I'll take you through the next 2-3 slides where I'm going to tell you about the different innovations which are done. Next, sir. For example, in 1903, the first electrocardiogram was found. From 1800 to 1850, the first modern stethoscope, laryngoscope, and ophthalmoscope was invented. 1895, the X-rays were invented. Next is 1927, the first modern respirator came into picture. 1928, the first cardiac catheterization was done. Then 1940, first metallic hip replacement surgery was done. 1945, the first kidney dialysis machine was invented. Next, please. 1951, the first commercially available artificial heart valve was invented. 1950, first artificial hip replacement, that is arthroplasty, was done. 1952, the first successful external cardiac pacemaker was invented. 1960, the first totally internal pacemaker was fitted. 1970, the first CT scan was done. 1976, the first replacement regulatory system for medical devices was done. At the same time, the first positron emission tomography was done, that is PET scan. Next is 1977, the first magnetic resonance imaging, that is MRI device, was found. In 1978, the first cochlear implant was done, that was mechanical. Then in 1982, the first permanent artificial heart was found. And in 1985, the first implantable cochlear implant was done. Also, the first robotic assisted medical procedure was performed. 1993, the first European Union for regulatory system was found. Next, sir. I will also quickly tell you some pharmaceuticals, like the invent of morphine, aspirin, ether, aspiramine, insulin, penicillin, chlorpromazine, halidol, estrogen, progesterone, digoxin, furosemide, atorvastatin, and HAART for the treating. That has really made a big change in the treating of AIDS patients. Next, let us see the future of healthcare innovations. I'm going to take you through 10 very quick innovations. So next one. And the next. So the first one is vaccines to prevent public health epidemic. We have just recently come out of a COVID pandemic, and we can understand, today's generation can definitely understand about what is an epidemic or a pandemic. But presently, the future is trying to get vaccines for Ebola and meningococcal B. This should get fast-tracked for approval so that patients can receive them earlier. Why could we control the epidemic, COVID-19 epidemic? Because of the fast tracking of the vaccine, how quickly it was invented and quickly the entire process was done. And hence today we are living in the, we are really out of the pandemic, and we are learning to live with the new trend. Next one in that is genomic directed clinical trials, genetic profiling of patients for better matches them to clinical trials, which increases their chance of benefiting from research studies. Next is CRISPR. It is pronounced as CRISPR, which is nothing, next one, which is nothing but clustered regularly interspaced, short, palindromic repeats. It is the hallmark of bacterial defense system, and it is a therapy in which the human genome is altered in an effort to eliminate genetic-based disease. Next one. Water purification system for prevention of infectious diseases. A self-sustainable processor turns solid waste and the sewer sludge into safe drinking water for hundreds and thousands of people. This is going to be the next future. Fifth one, cell-free fetal DNA testing. This will be done. It is a non-invasive diagnostic test, and it has 10-fold better chance of diagnosing Down syndrome in fetus. So it is going to be very effective and useful. Sixth one, cancer screening via protein biomarker analysis. Now, this is a test that detects changes in the structure of certain blood proteins, which can diagnose many types of cancer with high accuracy. Seventh one is naturally controlled artificial limbs. So the sensor picks up neutral codes which are sent by the brain and sends them to the computers to be deciphered and used to operate prosthetic limbs. Eighth one is first ever treatment for HSDD, which is hypoactive sexual desire disorder. It is if there is a persistent or a recurrent absence of sexual fantasies and desire for sexual activity. So a drug is would be the future, where the drug will restore the sexual desire in premenopausal women who have no medical based explanation for their loss of libido. Ninth one is frictionless remote monitoring. Devices that allow healthcare providers to monitor patients from afar. So next one, yes, from afar, and such as needle-free glucose monitoring, which uses biosensors on the skin to collect information of the glucose levels. And the 10th one is neurovascular stent retriever. This is a new device which is used alongside standard TPA, that is tissue plasminogen activator, which is a strong clot busting medication. This is given intravenously to dissolve the blood clot and to reconstitute the blood flow and oxygen to the brain. So a new device is used alongside this TPA treatment for stroke, and it removes clots and results in speedier recovery for patients, and they have a better chance for independence. Now I will tell you something. Next one. This is the first human head transplant. Head transplant is considered to be an extraordinary and impossible surgical procedure. And this innovative surgery promises life-saving procedure to individuals who suffer from terminal disease, but whose head and brain are healthy. So in 2017, Ren et al., they performed very successfully a cephalosomatic anastomosis using a human cadaver. And what they did is that there were two surgical teams who participated, and they worked simultaneously in order to conduct this procedure. Of course, leaving the ethics aside, we know that brain is a delicate organ, and the spinal cord which connects to the brain does not recover well after it is cut. However, the longest lived person has made it only to a few months. So though a few researchers have made headlines by claiming that head transplants in humans is just around the corner, but let me tell you, the hurdles are massive. Next one. Next is the robotic nurse assistant. Now these nurses, there are nurses who get injured every year from having to move or lift patients in the bed or after emergency from a fall. Now today I will introduce two new words. One is RIBA and one is HAL. RIBA is Robot for Interactive Body Assistance. Now this was developed by the company called as Riken. And this is the company, you know, RIBA. This was the first robot which can lift up or set down a real human from a bed to a wheelchair and vice versa. So RIBA does this by using its very strong human-like arms by novel tactile guidance methods, and it uses high accuracy tactile sensors. So RIBA was developed by integrating Riken's control, sensor and information processing and TRI material, and then this particular structural design has come up. Now what is HAL? HAL is hybrid assistive limb. Now this is a robotic suit which was delivered by a company called as Cyberdyne. So this is a company with the name HAL, and what is this robotic device? It allows the healthcare worker, so the healthcare worker can use this on herself or himself, wherein this healthcare worker, when he works with the patient to lift a patient, So there will be more stability and strength, and it will prevent injuries to our nurses. So it is worn like around the hip, and which will support the nurse's back and the hip and the knees, and she can move the patient easily. Next, we will move on to anti-aging drugs. Now, I don't know whether this is a dream or a nightmare, depending on how you take it, is living forever, or at least in the foreseeable future to 120 years plus years of age. So already the anti-aging drug test has entered into the trial phase, which could see diseases like Alzheimer and Parkinson's. Maybe it will be consigned to a distant memory. So scientists now believe that it is possible to actually stop people growing old as quickly and help them to live a good health well into their 110s and 120s. Next, please. Now imagine you are in the ICU and you just switch on the light bulbs and automatically the entire ICU gets disinfected and it kills the bacteria. So this is the new kind of the future technology which we will be having very soon. And instead of doing all the fuming and the kind of things we do in order to disinfect our ICUs after our patients are discharged. Next is electronic underwear, which prevents bed sores. So we are having elderly people who have died from complications due to bed sores. Now this is extremely unfortunate because these issues could be prevented. So when the patient stays motionless for days and weeks or months, they develop a very painful open wound due to lack of circulation and compressed skin. So this is the new kind of innovation which is soon coming into the market. Next. Next, please. Next. Next is long-lasting batteries. Now, batteries that are typically, we know that batteries need to be replaced with an expensive surgery. So with the need for power-hungry devices comes the innovation in the form of new technology that will help provide the world with longer-lasting and faster charging batteries. Perhaps batteries' most impressive quality. Okay, next one, sir. That is aluminium-ion batteries. There was a chemistry professor with the name Honji Dai from Stanford University, and he has invented aluminium-ion battery prototype. It can fully charge a phone in 1 minute and maintain its strength through thousands of recharge cycles, over 7 times as many cycles as the current phone batteries. So perhaps the battery's most impressive quality is its flexibility, meaning it could work with any future device which is curved or bendable, whatever it could be. This particular battery will be compatible with it all. Next is the micro supercapacitor. And here I've used the word Rice's micro supercapacitor, charges 50 times faster than batteries, discharges more slowly than the traditional capacitor. So what is rice? Rice is the rice husk or the rice stem, which is actually an active material which is used as a supercapacitor. And if you just do Google search on this, you will find a lot of scholarly articles in your search. So you could do that after this after this conference is done. So they match the commercial supercapacitors for both the amount of energy stored and the power delivered. Next, we'll go on to foam batteries. The future of batteries is 3D. Pareto is the first company to crack this with its battery that uses a copper foam substrate. This means these batteries will not only be safer thanks to the no inflammable electrolyte, but they will also offer longer life, faster charging, five times higher density. It will be cheaper to make and it will be smaller than the current offerings. Next is the skin power. Researchers from National University of Singapore, they have created a replacement for batteries altogether. Imagine that. It would be an electrode which will be used to harvest the current caused by friction on the skin and clothes. So the result is enough power to form a finger tap on skin to power a 12 LED bulb. Imagine how wonderful that would be. And the future would mean that there is no need for batteries in any wearables or smart clothes. Next. Now I'm going to discuss very quickly about some very weird but wonderful surgical procedures which have already taken place in the world. The very first one is rotationplasty, that is turning the ankle into a knee. So rotationplasty is an extraordinary form of reconstructive surgery that enables the ankle to be used as a knee joint. The procedure involves the surgical removal of the bottom of the femur and the knee and the upper tibia. And the lower part of the leg is then rotated 120 degrees and it is then attached to the thigh. Put simply, the foot is attached to the knee backwards. And once the prosthesis is fixed, or fitted, the ankle of the foot functions as a knee. So rotation plasty is very commonly performed in children who have malignant bone tumors such as osteosarcoma or Ewing sarcoma, which is near the knee, that have not responded to any other treatments. Next is osteoodontic keratoprosthesis. This is also called as OOKP. The other name for it is restoring sight with a tooth. So tooth is used to restore the patient's sight. This procedure involves the removal of the patient's canine or a premolar tooth and the surrounding bone, and the technique uses the patient's own tooth, as the body is unlikely to reject it, because we know about rejections, graft rejections. So a hole is then drilled into the tooth and the plastic lens is then inserted into it. And this lens tooth structure is left or implanted into the patient's cheek, where it grows new blood vessels over the few months. And then this structure is removed from the cheek and implanted into the eye. Now light is able to travel through the lens, and thus it restores the patient's vision. Next one. Is removing half of the brain. It is called as hemispherectomy. Now, the brain is the most complex organ of the human body. It contains billions of nerve cells that acts as the command center for the physical and psychological functions. So what is hemispherectomy? It involves the partial or the total removal of disconnection of one or two hemispheres of the brain. And it is considered as a radical procedure. It can take as long as 12 hours for the surgery to be done. And one of the two hemispheres of the brain is removed or disconnected. And in this procedure, usually the individuals who have a neurological disorders which causes seizure on one side of the brain, like epilepsy or maybe perinatal stroke, or hemimenengocephaly, where one side of the brain is larger than the other, or it could be Sturge-Weber-Dimitri disease, which is characterized by facial birthmarks or glaucoma and seizures, or it could be Roseman's encephalitis, which is the inflammation of the cerebral cortex. Next one is heterotrophic heart transplant. Next one. So it is said that two hearts are better than one. What happens here? It is also called as a piggy bank heart transplantation. It involves implanting a healthy donor heart on the right side of the recipient's damaged heart. Now, both the hearts are surgically attached. This allows the blood from the damaged heart to flow into the new heart, and the new heart can then pump the blood around the body. So to conclude, I would like to say that the last 75 years of medical innovation have been more productive than rest of the recorded human history. 21st century is the era of innovation for innovation. However, the best is yet to come. We have miles to go. These are the books that I have referred. Next one, sir. Next one. But before I say a thank you, I would like to take you, sir, next one. I would like to take you through a few slides where I will tell you about the recent researches which are done. Sir, next one. Next one. Next one. So this particular research I found in the Journal of Business Research. The title was Innovation in Healthcare, Issues and Future Trends. This is a study which is done overseas and published in 2012. And it shows how executives and practitioners will define the term innovation in healthcare. I found yet another research, next one, next one, please, which was found in a journal, back please, in a journal called as the Innovation Journal. This was published in the year 2010. So Innovation in Healthcare Delivery System, a conceptual framework. So it is based on the proposed definition of healthcare innovation and the dimensions. Then the conceptual framework was developed, and this was published way back in 2010 because it was a new term altogether. And one more I would like to end with before I end. This was published in the Future Healthcare Journal. This is about promoting innovation in healthcare. Again, it is a study which is published overseas in 2017. And important issues of funding, actually, where healthcare is concerned and innovation is concerned. Anuradha, if you could please mute yourself. Yes, thank you. So important issues of funding, information on governance, interoperability, medical device regulation. These are all challenges for increasing innovation. So based on this particular study was done, wonderful findings. And if you are able to read, do try to go through and have a look at it. So with this, I would like to end my presentation and thank you very much to all the organizers for giving me this chance to speak to all of you today. A real August gathering, and I'm really grateful. If any questions you could ask.
Hello, ma'am.
Yes, Yogita.
Hello. Yes. Good afternoon, madam. After a long time, it was very nice to hear you. You have highlighted and we were imagine what could be the next scenario, and we will going to face it, and it's a mind preparation forward to deal with the situation and challenges. So thank you very much for giving us the insight about the overview of AI in our life, and especially in the nursing education, clinical settings, practice, and research. Thank you so much, ma'am. Thank you.
Yes, thank you, Pradya. Thank you, Yogita, for that input.
Thank you, madam. Thank you, Rupali Salvi, madam, for insightful and very informative presentation. I hope every participant has got much more information about innovative healthcare technology and innovative idea in healthcare. As artificial intelligence is widely used in hospitals as well as college nowadays. So everybody will be benefited by this conference. Thank you, ma'am. Thank you so much for joining us.
Thank you, sir.
Now come to the end of session, and I would like to invite Dr. C.P. Sharma sir for vote of thanks. Dr. C.P. Sharma sir is President of Federal Organization of Nursing Services and also currently working as a principal in BDM College of Nursing, Jhajjar, Haryana. Sir, over to you, sir.
Yeah. I'm audible. Dear all, good evening. Myself, Dr. Professor C.P. Sharma, Principal BDM College of Nursing, Chuchukwas. On the behalf of the organizing committee of this online conference is organized with the collaboration of FONS and Vedanta College of Nursing, Gujarat. I extend my sincere gratitude to all our esteemed speakers, participants, and volunteers for making this virtual conference success. Your valuable contributions, engaging, discussing, and unwavering support, we are truly enriched this event. We are immensely grateful for your commitment to advancing knowledge and fostering collaboration in this national conference. Thanks you once again for being a part of this inspiring journey. We look forward to seeing you at future events. Thank you, dear all. Lot of thanks to all.
Thank you, sir. Thank you very much. And now I would like to inform you that those who will be presenting paper will join the link provided to you, and other may leave the meeting now, and every participant will get e-certificate within 1 week on their email ID. Thank you so much. You can leave the meeting now. Only paper presenter will be joined by the separate link provided. On the WhatsApp. Thank you so much.
recording